All computers work on exactly the same model. They receive input from keyboards, the mouse, touchscreens, and even microphones, to name but a few. The central processing unit and memory then process this data in some way and output the information to the computer screen, the printer, or even the speakers. Again, there are far more output devices than mentioned now. The third branch of the model is storage, which is our topic for today. Computers can store vast quantities of data and retrieve this information at remarkable speeds. Our world is full of databases of stored data. Your local security agency and Big Brother are out there. Computers store all of this data in binary format. Binary is a series of ones and zeros representing off and on signals. Each individual signal is called a bit. We require 8 bits to store a single letter or punctuation character. These 8 bits are called a byte. For example, the capital letter C is 01000011, and the percentage sign is 00100101. Binary is also used to store numbers. The largest number that a single byte can store is 255. Binary is also used to store pictures by storing the location and color of individual pixels as numbers. Kilo is a decimal prefix that means 1,000. Therefore, 1 kilobyte is 1,000 bytes. Kilobytes are often confused with kibibytes. Kibi, by contrast, is a binary prefix, which is denoted by 2 to the power of 10, which is 1,024 in decimal. 1 kibibyte is therefore 1,024 bytes, but sometimes you'll see 1 kilobyte as 1,024 bytes, which is technically incorrect. You will thank me for this useless information at your next dinner party. Right, if you have kilobytes, you're looking at documents. If you have 1,000 kilobytes, you then have a megabyte. With megabytes, we're looking at pictures. 1,000 megabytes will give you a gigabyte. Most HD movies are a few gigabytes in size. 1,000 gigabytes will give you a terabyte. Most entry-level computers have terabyte hard drives. 1,000 terabytes, you're looking at a petabyte. Corporate servers would have petabytes worth of storage. If you have 1,000 petabytes, you have an exabyte. Cloud storage like iCloud will be in the exabyte range. 1,000 exabytes, you then have a zettabyte. The National Security Agency in the United States is claimed to have zettabytes worth of surveillance video. 1,000 zettabytes gives you a yottabyte. It is estimated that the entire internet contains a single yottabyte of storage. This is the largest storage unit available at the moment. We use hard drives or hard disks to store data. Hard drives contain multiple magnetic platters that spin at 7,200 RPM, as fast as your car's engine. Read-write heads then move up and down the platters to add or read charged sectors. This is the whirring sound you hear when you open a file. The file is then loaded into your memory, and then you can see it on your screen and manipulate it. There is a very important difference between memory and storage. Think of storage as a filing cabinet. Computers use their hard drives exactly like filing cabinets. You cannot open a file while it's still in the cabinet, which is why we need a desk. Files open up on the desk, and then we can work with it. The larger our desk, the more files we can have open at one time. If our desk gets full, we will need to take the files back to the cabinet before we can open up any new ones. Our desk is an example of computer memory. Memory is the working area of the computer. The more memory we have, the more files we can have open at the same time, and the faster our computer operates. When we open a file, the computer goes to the hard drive and loads the file into memory. While it's in memory, it is volatile, which means we can lose the data. Memory uses capacitors that store charge to represent binary. A charged capacitor is 1 and an uncharged capacitor is 0. This simplicity allows the memory to work at remarkable speeds, far faster than hard drives. Memory running at 3200 MHz performs 3.2 billion cycles per second. If the computer loses power, or the program is closed without saving, all the capacitors are drained of power and the data is lost. As soon as you save a document, it copies everything from the memory back onto the hard drive, and your data is then permanent and no longer volatile. It is good practice to save your work regularly and set automatic saves if your software allows for it. Most hard drives contain moving parts, as well as a magnetic disk. The exception is solid-state hard drives, which operate like flash memory without moving parts. The file copy speed of a normal hard drive is between 80 and 100 megabytes per second. Solid-state, you're looking at 200 to 550 megabytes per second. File opening speeds up to 30% faster with a solid-state drive. The cost, however, is 4 times as much. Magnetic hard drives will, however, suffer from wear and tear and eventually fail. It's important that you back up important files on your hard drives. Most of our photographs are stored on our hard drives. Can you imagine losing all your memories? Backups also protect you from viruses and data corruptions. Most operating systems have backup programs that will run backups for you automatically. Otherwise, you can purchase an external hard drive or a flash drive and manually copy your important documents. Making use of cloud services like Microsoft's OneDrive, Google Drive, or Apple's iCloud to store your data makes backups unnecessary, but there are costs attached. Backing up is incredibly important. It's only when you lose valuable information do you realize just how important it actually is. YouTube stores 100 hours of video every single minute. This translates to 269 terabytes of storage every single day. Every day, we upload 200 million photographs to Facebook and 1.2 billion pictures to Google Photos. Today, it is estimated that 2.5 million terabytes of data is produced worldwide every single day. Where we're going to store all this data is going to be a challenge. The scientists are working on new technologies that will use electrons, atoms, and subatomic particles to process and store data. So if you think you have information overload now, just wait.